Alright, I've given you this worksheet today as a sort of way to review our rules that we learned yesterday. And writing them down again always helps us remember them better. Okay, so let's talk through this a little bit. Yesterday we talked about the fact where if we have log base b of x times y, what does that mean? So it would be log base b of x plus log base b of y. Right? You remember that? Okay. The log of a product is equal to the... While addition is true, it doesn't really work in the sentence. But I'm glad you know it's addition, okay? But the word we want is sum. Okay? The log of a product is equal to the sum of the logs of the arguments. Yes? Okay? What about this next one? Log base b of x over y. Log base b of x minus log base b of y. So the log of a quotient is equal to the difference. Good. Of the logs of the arguments. Now, what about this last one? Log base b of x to the p power. What's that equal? P log base b of x. Good. The log of a number raised to a power is the same as the... There really should be two blanks here, just so you know. Blank, blank, the log of the argument. The log of the number... Sorry, the log of a number raised to a power is the same as the power... What? What's the verb? Times? Oh, we can use times, that's fine. Times the log of the argument. It actually is the right verb because we're not saying it's, we're timesing, right? Because we don't want to say that. But it's the power times the log. Multiplied by the log. That's all good. Okay? Now, these next two, you actually haven't seen before. But I didn't show them to you yesterday. First of all, because we didn't have any situations where it would come up in any of the homework yesterday. And second of all, they're just really easy. Okay? So I figured you could handle getting a couple new notes today as well as the problems we're going to do. Okay? Log base b of b to the p power. Okay? So we're going to think outside the box for just a second. Log base b of b to the p power. Well, if I rewrote that, it would look like p... What? Excuse me. No, we're not going to do it that way. We're going to do it this way. What if I rewrote this in exponential form? It would be b to the something power, we don't know, equals what? B to the p power. What's the something we don't know? Yeah, obviously it's p, right? So do the problem that they have here written for you. Rewrite that in exponential form. 2 to the x power equals 2 to the 6th power. So what does x have to equal? X has to equal 6. So cover this up. Cover the writing up. The words. Look back over here. Can you tell me a sentence that would work for this and that would work every time? Without having to rewrite it, just something to look at right here. Yeah, exactly. When the base and the argument are the same, what's the answer? Exponent. Okay? When the base and the argument are the same, the answer is the exponent. If the log base and the argument are the same, it's always equal to the power. Well, isn't that what we said? Good. So now we'll do a much harder one. This one. Wait, what rule did we just learn? If the base and the argument are the same, it's always equal to the exponent? What's the exponent? 1. If the base and the argument are the same, the answer is the exponent. It's really the same rule. They have it separated in case there's quote-unquote not an exponent written. But we all know that there's always an exponent written. It's always a 1. So we can use exactly the same rule, can't we? Okay? Now, let's go ahead and do this one, just because we like to follow the rules and do all the examples. 2 to the x power equals 2, so x has to equal 1. If the log base and the argument are the same, it is always equal to the understood power of 1. It's the same rule, though, isn't it? If the base and the argument are the same, the answer is the exponent. Okay? Now, I left this line on here mostly just for laughs. Mostly just because I find it funny. Okay? The change of base property, or the change of base rule. Because a long, long time ago, in the land far, far away, we had calculators that would only do base 10. And if you had a calculator that only, well, actually, if you want to get technical, a long, long time ago in a land far away, we didn't have calculators. We had to do logarithms with logarithm tables. Find this table for you real quick. I want you to see it. I want you to see what your parents had to do. Some of your parents had to do when they were doing logarithms. This is what they used to solve logarithms. So you had to know an n value, you had to know a other number value, and you had to, oh, that's the answer. We don't have to use these anymore. Okay? And this book is interesting because it's only a front and back page that's a logarithm table. Okay? Other books that I've seen before had several more pages of logarithm tables that they had to use to solve logarithms, which is maybe part of the reason why your parents hate logarithms, because they were awful. Okay? Then we got these calculators, and these calculators are all nice and good, but you notice there's only this button right here that says log, and then there's, of course, the natural log button right below it. Okay? This log, let me turn it on. When you press log, it's just log. All you can do is log base 10. That's it. It's a common log. And then we have these. And some of you I know have messed already around with these, which is what I expect, and that's fine. And so some of you have noticed that if we're using the calculator tab, and we press log, which is of course the blue control button right there, what can you do? Not only can you put an argument in, you can put a base in. This calculator will do any base at all. Okay? So even with the whole log tables, they had to know the change of base formula. Even with the old calculators that we used for even 4 or 5 years ago, you had to know the change of base formula. Okay? Now if I want to figure out log base 4 of 32, I press in log base 4 of 32. And I get 2.5. Okay? But for kicks and grins, whoa, how about 2.5? Because I said 2.5. Just for laughs, I really actually want to show you the change of base property. Okay? Change of base property will automatically change it into a base of 10. Why do I want to change it into a base of 10? Because I could do it that way, right? Either with the tables or with the calculator, I could do it that way. So I would do log of n divided by log of b. I would take the log of the argument that I was currently taking and divide it by the log of the base that was there. Okay? So I'm going to press log of, whoop, you can't see that. If I did log of 32, whoops, and I have to actually scoot over because it won't do it for me like that. Now, what's going to happen if I leave that base blank? The calculator will know that it's log base 10, okay? And divided by log of, what did I say? 4. Look. See what it even wrote? It automatically filled in the tens, and it's still 2.5. Okay? I just wanted you to know the change of base property because look what happens here. If I need to write this as a function, so that maybe I need to graph it, and I maybe don't have a calculator that will, I don't know. We would say f of x equals the log of x plus 1 over what? Log of 2. Yeah. We're not going to need to do the change of base property in this class when we do our calculations, because we have now technology that will do that math for us. But you know how I feel about the technology. We can only use it if we understand the math. This is the math going on behind why we can put this directly in. Fair enough? Okay. On a separate sheet of paper, because I don't think you have enough room on that, a piece of notebook paper or something, I want to show you 2 examples of the problems that are on the back of this worksheet. Okay? 2 examples. The first problem, we're going to actually start using all those properties that I taught you yesterday and that we went over today. So here's our first problem. Log base x of 5 plus log base x of 20 equals 2. So, what do you think I want to do? What would you want to do? You want to combine them? John, how many times do we actually want the word log written? Only once. Okay? If I can get everything together in one logarithm, I have a better chance of being able to solve it, depending on the situation. But most of the time, that's true. Okay? So, how would I go about rewriting this?
Would you convert it back to regular form?
What do you mean by that? So, I want to condense it using all my rules that I just went over. How would I condense this? Log base x, what does that mean? Multiply. So 5 times 20. Okay? I'm going to write this first. Not that you need it, but just in case somebody who's watching the video does. Okay? Now we know that that would be log base x of 100 equals 2. Now what? What do you think? For the record, over the next couple days when we're working on solving logarithms, there's going to be different strategies for different problems. Okay? When I'm working on logarithmic equations and I get it with one log going on here, the very first thing I always try is, will exponential form help me? Can I put it in exponential form? Okay? So let's try that on this problem. Can I put it in exponential form? Yeah? X squared equals 100. How do I solve it? We'll talk about your way in just a second. Let's how do I solve this one from here? Square root of both sides. X equals what? Don't forget. Don't forget. I'm taking the square root of 100. What's the square root of 100? 10 or negative 10. Remember that? So then I need to see, is this a reasonable answer? I need to decide, is this a reasonable answer? If you look up on the board up there, that's one of the things we're supposed to have to talk about. Well, we should anyway, though, right? Is this a reasonable answer? Well, first of all, how many answers do I have? I have 2. I have a positive 10 and a negative 10. Is it a reasonable answer for this problem? So, think about this for just a second. 10. Log base 10 of 5 plus log base 10 of 20 equals 2. That makes sense, right? That's something I could definitely put in the calculator and check. Log base negative 10 of 5 plus log base negative 10 of 20 equals 2. Does anything seem off about that to you?
Wouldn't it still the same if you multiply two things
Now, we kind of got lucky right now because this is a 2. Alright? But think about it in general. If I'm here and I rewrite this into exponential form, is there any negative number that I could raise to a power that would give me a positive number? Even powers, I agree with you, right? But as a general rule, do you think that I should have negative bases of my logarithms? No. No, I should not. Okay? So while this is the answer to this simple equation right here, what's the answer to my logarithm problem? Yeah, x equals 10. That's the answer to my logarithm problem. Do we have negative bases? No. No, we don't. Okay? Any questions about that problem? And let's do this one. Log base 8 of x minus log base 8 of 4 equals negative 1. So I want you to keep this in mind as we're going. Are logarithms allowed to equal a negative number? So let's work through it, and we'll decide at the end if our answer is reasonable. Okay? What do you think I should do first? Yeah, I want to condense it, don't I? Okay, I want to write it as one logarithm. So log base 8 of what? X over 4, good, equals what? Okay, negative 1. What should I try? Exponential form. Right? Try exponential form. Rewrite the logarithmic form into exponential form. 8 to the negative 1 power equals x over 4. Do we know 8 to the negative 1 power without touching our calculator? 1 over 8. 1 over 8 equals x over 4. Is that an equation I could solve? Yeah, without any problem, right? How would you solve this? You would cross multiply? Okay, we can do that. So 4 times 1 is 4. X times 8 is 8x. Very good. Divide both sides by 8. X equals what? What's 4 divided by 8? 0.5 or 1/2, right? So is that a reasonable answer? Remember, if I put that in exponential form, where does it go? To the exponent, right? Am I allowed to have a negative exponent? Yes. So is my logarithm allowed to equal a negative number? Yes. Okay. Any questions? These are the kind of problems that you are going to see on the back of your worksheet. These 6 problems right here. Okay. So go ahead and get started on those, and hopefully you will finish before the end of the period. Are there any questions?